Hello guys, and welcome to my second video covering the inequality 2 is less than e less than 3 less than pi less than 4, and we already proved that 2 was less than e, which was less than 3, and now we're going to prove 3 is less than pi is less than 4. And if you type into a calculator pi equals, you'll get an answer 3.14159263, etc., depending on the memory of your calculator. So from that, it's obvious that it lies between 3 and 4. But unfortunately, that's not a rigorous proof. Now we're going to show why this happens, and we're going to show only that it's between 3 and 4. We're not going to show that it's equal to 3.14, 15926, etc. We'll maybe cover that in another video. So basically, I'm going to do this in two parts. In the first part, I'm going to show that pi is less than 4. That's probably the easier part. And then in the second part, show that pi is greater than 3, which is slightly more tricky. So unlike the video where we were looking at e, we used mainly algebra in that video. Here we're going to maybe use more geometry alongside some well-known results. We won't necessarily prove the results, but I can make other videos on those later. Results we will use include equation of a circle, the sine rule, trigonometric laws, area of a circle formula, circumference of a circle. So for the equation of a circle, we have x minus a squared plus y minus b squared equals r squared. And that's the equation for a circle centered at AB, where a is the x coordinate, b is the y coordinate, and radius r. So if you set a and b equal to the origin, 0, 0, then it would just be x squared plus y squared equals r squared. And that looks very like Pythagoras' theorem, doesn't it? Where you have two sides of a triangle, x and y, and the hypotenuse r. We're not going to be covering Pythagoras in any great detail in this video, but it just shows you the link there. So for the unit circle centered at the origin, the equation will be x squared plus y squared equals 1. For this proof, we will use the circle centered at the origin with radius 2. That will become clear later why we're choosing that. It's just easier to work with for this proof. So that means we're going to be using the circle x squared plus y squared equals 4, because r is 2. So you square 2, you get 4. So this will form the basis of our geometric proof that shows that 3 is less than pi is less than 4. The great thing about this proof is we don't need to know the exact or actual value of pi. We just need to use the famous results. The area A of a circle of radius r is given by A equals pi r squared. We won't prove that in this video. And the circumference C of a circle of radius r is given by C equals 2 pi r. We won't prove that either in this video. Those formula hold for any value of r greater than or equal to 0. Obviously, if it's equal to 0, then the area is clearly 0 and the circumference will be 0, because all you would have is a point. So you don't have any area or circumference in that situation. So for practical purposes, you need r to be bigger than 0 to have some sort of structure, so you can see some sort of circle and some sort of circumference. So here's a quick glance at the graph. X squared plus y squared equals 4. So there you go. You can clearly see that the x-axis ranges between -2 and 2. It's centered at 0, the origin. So the radius there is clearly 2. Diameter is 4. And then the y ranges from -2 to 2 as well. So it's pretty obvious to see that the radius is 2. And what that means is you take any point on the circumference, draw a line to the origin, the length of that line will be 2. It's always going to be 2. That is essentially what a circle is. It's equidistant from the origin all the way around the circumference. Now for the sine rule, we will use the area of a triangle is equal to a half of a times c times the sine of b. Now I've written a and c in small letters and b in big letters. The reason I've done that is because a and c represent sides here. So the length of a side A and the length of a side C, and the capital B represents an angle. Now that would be the angle opposite the side B, small b. So in other words, you've got two sides, A and C, and you've got an angle B between them. And that's all we need to know to apply the sine rule. So A and C are the length of two sides, and B is the angle between them. Example, compute the area of the following triangle. So you've got an equilateral triangle there. It will become clear, if it's not already obvious, why it's equilateral. But you know that the sum of the angles in a triangle adds up to 180 degrees. And you've got two sides there which are both length 6. So that means the other two angles have to be 60 as well. And that means the other side will be 6 as well. But we don't need to know that to apply the sine rule. All we need to have is two sides and an angle between them. We can use that sine rule formula. So that's what we have. So to work out the area of this, we use that formula, and we get the area equal to half times 6 times 6 times sine of 60, which is equal to 18 sine of 60, which is 9 root 3. You can do that in your calculator and check it. And we're using degrees here for our angle units. We're not using radians or any other unit. Okay, so we can now load up a graph and actually prove the inequality. So please follow closely on the screen to what I'm doing and saying. So let's consider this diagram. So I've drawn my circle, I've drawn a large square around it, and that square has 4 little squares inside it, and then inside one of the little squares in the top right, I have drawn 3 triangles. But you'll notice that those 3 triangles are within the boundary of the circle. They're inside the circle. Now that's very important. So first of all, I'm going to prove that pi is less than 4. So let's consider the circle. The area of the circle is pi r squared, which is 4 pi. So that means the area of one of the sectors, which is a quarter of the circle, inside one of the little squares, is pi, because you've got 4 of them, and they're all equal area because it's symmetrical. And the area of one of the little squares is 2 times 2. It's pretty obvious from the diagram, because the radius of the circle is the length of the side of one of the small squares. So that's 4. So therefore pi is less than 4. So when we say pi is less than 4, geometrically, if you look at the shapes on that diagram, that's the same as saying the area of one of the sectors, which is a quarter of the circle, is less than the area of one of the little squares, which is a quarter of the large square. So that means we've proved pi is less than 4. Now for the trickier part, we're going to prove that 3 is less than pi, or pi is greater than 3. So let's consider one of the sectors. The top right square has a sector inside it, and inside that sector you'll see that I have 3 triangles. Now they are inside the sector. The upper edge of each of those triangles does not break over the circumference. It's inside the circle. That's very, very important. So all we need to do now is show that the area of those 3 triangles is equal to 3. And if we can do that, then we've shown that 3 is less than pi. And it's all basically done using areas. So we've got 3 of them, and they're all of equal area. So we just need to show that one of them is equal to an area of 1. So how do we do that? Well, if you consider the red line, which is going from the origin to the circumference, and you consider the black line going from the origin to the circumference, those 2 lines have a length of 2. Why? Because they're equal to the radius of the circle. Because that's what a circle is. A circle has a radius, which is the distance from the center to any point on the circumference. Any point, guys. So it's always 2. So now we need to look at the angle between them. So the x-axis and the y-axis have an angle between them of 90 degrees. It's a right angle. That's pretty obvious. It's also inside the square, and a square has equal sides and equal angles, and they're all 90 degrees. And we've split it into 3, because those 3 triangles have an equal area, they have equal angles. So they're all 30 degrees. 90 divided by 3 is 30. So we've got 2 sides, 2 and 2, and we've got an angle of 30 degrees. So consider the middle triangle, guys. One of the sides is the red line, one of the sides is the black line, and the angle between them is 30 degrees. So we're now going to apply our sine rule formula, half AC sine B, which is a half times 2 times 2 times the sine of the angle between them, which is 30. So a half times 2 times 2 times the sine of 30, and that's equal to 1. And you can check that on your calculator. Just make sure you're using degrees and not radians. So if that area is 1 for that middle triangle, and they're all the same area, those little triangles, then the total area of all 3 triangles is 3. So there you go, we've proved that 3 is less than pi, because those 3 triangles are inside the circle, they're inside the sector, which has area pi. So to summarize, we showed that the area of the quarter circle, or a sector, was pi. We showed that the area of one of the little squares was 4. So the area of a sector is less than the area of a little square, i.e. pi is less than 4. We used the sine rule to show that the area of one of the triangles was 1. A half times A times C times sine of B equals a half times 2 times 2 times sine of 30 equals 2 sine 30 equals 2 times a half equals 1. The sine of 30 is a half. You can check that on your calculator. Use degrees. And that the 3 triangles are all inside the sector, as the small side does not cross the circumference. So the total area of the 3 triangles is 3 times 1, which equals 3. And that must be less than the area of the sector, which was pi. i.e. 3 is less than pi. So there you have it. We've proved that 3 is less than pi is less than 4. So that concludes the video. Have fun with pi. Thanks for watching. Please subscribe, and I'll see you on the next video.